right, I was just kind of, I don't know why I put all this on here. Every lesson in your book has this lovely little thing of like what you're going to learn about and why it's important. And sometimes I just throw it in there, sometimes I don't. But we're getting really close to this fundamental theorem of calculus, which is kind of very important, why it's called the fundamental theorem of calculus. And once we learn it, like we will use it in every single thing that we do. We'll be like, let's apply, and we don't even call it, we just write it FTC, Fundamental Theorem of Calculus, because we say it so much. So today we're just going to kind of go through some properties, which is the main reason that I printed this out for you, is I didn't want to have to, have to write all these down and waste a lot of time, and then I just wanted us to talk about them, so maybe if you feel like you need to write something down, jot a note down as we're doing these. But these are some rules for definite integrals. A lot of the same rules for indefinite intervals, like that you can pull a constant in front and addition and subtraction you can break up. But there's definitely some things for definite intervals that are different, like this one. We always know that a is the smaller number and b is the bigger number. And so notice on this one, it says if it has the integral from b to a of f of x dx, b is always bigger. It's always the interval from a to b. So you have to flip that backwards, and you have to put the a on the bottom and the b on the top. And when you do that, you pull a negative out front. And so this one, we're going to practice it. But it's one that can kind of trip you up a little bit. But a always has to be on the bottom. So if it's not, then you have to pull out that negative. Okay? I love the little reason. A definition. Also a definition. This one, if you have the integral from a to a, think about what that would be when you made a shape there. If you're just looking at one point, do you agree that the area is always going to be 0? Like there's going to be no shape formed. So that kind of makes sense that if you're taking the integral from a to a, then your answer would always be 0. Constant multiple, this one is the same one as the other ones, which means I feel like we're good at this one already. But anytime there's a constant in front, you can always pull that out front and then multiply it back in after you evaluate the integral. And the same thing with a negative. A negative is just like a constant. I don't know why they write it as a separate thing. But if you have a negative function, you can pull the negative in front. Notice nothing has changed with the bounds. You're just factoring out that constant, evaluate the integral, multiply it back in. Kind of like the one on your calculator that we just did. You evaluate the integral and then multiply by 2. Yes? Maybe that's just an example of that. This one is also just like the one that we've done already. We don't have a chain rule. We don't have a product rule. We don't have a quotient rule. But we can break up addition and subtraction. So right now, unless we're using our calculator or an area formula, we don't have a way of evaluating this except for we're allowed to break this up. And notice the bounds are the same. So again, that one's pretty good. This is a good one. Additivity. Apparently it is. There's lots of words I think that are only words in math class. And like, if you use them outside math class, people are like, that's not words. Differentiation is in every education class, because you want to differentiate your curriculum, which doesn't mean take a derivative of it. It means vary it, like reach everyone. Differentiate. So, all right, how about this? This says the integral from a to b of a function plus the integral from b to c of the same function is equal to the integral of a to c of f of x dx. This reminded me, I don't know how much you remember from geometry class. It's been a while. I'm weird and I remember a lot of geometry. This kind of reminds me of the segment addition postulate. I'm sure you all have that memorized, right? The segment addition postulate in geometry says this is A, this is B, and this is C. Do you agree that AB plus BC is going to equal the whole segment of AC? Yes? That's the segment addition postulate. This just says the same thing holds true for integrals. If you take the integral from A to B of whatever function, whatever curve is up there, you get this area. And you add that to the integral from B to C, this area, that's the same as if you would have just taken the whole area or the whole integral from A to C. Yes? A lot of your homework today is going to be using that formula in that you're not going to actually be evaluating anything, You're just going to be kind of putting stuff together. And so that one shows up on AP questions as well to see if you know how to kind of set those up. Segment addition postulate. Why I remember that. And a postulate, do you remember what a postulate is? It's not as important as a theorem. It's kind of like just because it makes sense. Yeah, like there's not even really a proof to go with it. It's just like common sense, kind of like it makes sense, so we'll call it a postulate. All theorems have a formal proof that goes with it. So how about that? See, look, we remember stuff. How about this one? This one's kind of weird. Maybe just say, oh my goodness. Is 7 on your paper? Max-min inequality. I think the best example of this is when we just actually do one with numbers. But if they ask you to find about the maximum min of an integral, they say that the integral itself from a to b is always going to be in between the minimum of the function and the maximum of the function over that same interval. We'll come back to that one in a minute. About domination, I kind of forgot about that. I don't even know what this says. Let me read it. F of x is greater than or equal to g of x, then the integral from a to b is also greater than. If the original function is bigger than another function on a given interval, then the value of the integral is also going to be bigger than the other one. I don't really feel like that one's very useful. I feel like this one is the one we're going to be using the most. So it says if the function is greater than or equal to 0 over the interval, then the integral is also going to be greater than or equal to 0. Same would hold true the other way. If the function is less than or equal to 0 to begin with, then the integral on that interval. I find saying integral and interval so much, I'm always worried I'm saying the wrong thing. Integral. The integral of the interval. Okay, let's do some. This is what your homework is, a lot of it. It says, given some things, find the value of all these using these properties. So, can you read these? It says the integral from -1 to 1 of f of x equals 5. So they're giving us the answer on that one. The integral from 1 to 4 of that same function f of x is equal to -2. And then the integral from -1 to 1 of h of x, so we've changed functions, is equal to 7. So using these values and using the formulas that I gave you, we want to see if we can find the answers to these. So, you want a minute? What we're going to learn this week, tomorrow, how to make the integral of inverse trig functions. Haven't you missed those inverse trig functions? No? Nothing? Feel free to work it out. I want to point out that it says if possible, because sometimes it's not possible with the information that they give us to do some of these problems. So we want to kind of see what can we use these properties for, and what can we not just jump to and say, well, we think this is going to happen. And some of these are not enough information. So what about part A? What do you think we should do for that? Right? You see how it's up here, we have 1 to 4, and this one's 4 to 1, right? The number is bigger than the top, so we need to turn that around, and we could say that would be the same as saying from 1 to 4 of f of x dx if we pull that negative in front, right? And then the value of that integral is -2. So I think the answer to A would be 2. You agree with that? What about B? This is that additivity, I think. It's the one that I think we're going to use the most of these formulas, besides like breaking up, which we know how to do. I want to go from -1 to 4. So again, just think about, like sometimes it helps me to draw a picture. I have from -1 to 1, and I have from 1 to 4. And if I know -1 to 1's value is 5, and from 1 to 4 value is -2, and I want to find the whole thing, agree that's going to be equal to the two parts. That's equal to the integral from -1 to 1 of f of x dx plus the integral from 1 to 4 f of x dx. And you don't have to write all this out every time on your homework. I just want to kind of show you where it's coming from. It has to, like the upper limit on this one has to be the lower limit on that. Like there can't be a gap in between, because then we don't know what that area is in between that. But we do know from -1 to 1 is 5. We know from 1 to 4 is -2. So I believe the answer to part B is 3. Agree with that? What about C? Can we do part C? What can you do when there's a number in front of a function? Factor it out front. And what about addition? Can I break that addition up as two separate integrals? I can, yes. And again, probably you're not going to show all that work every time, but because it's our notes, I'm just going to show you that this is the same as saying 2 times the integral from -1 to 1 of f of x dx plus 3 times the integral from -1 to 1 of h of x dx. That's just using those properties. I'm going to work up here. So I'm going to get 2 times the value from -1 to 1 is 5 plus 3 times the value of h of x from -1 to 1 is 7. So 10 plus 21, did you get 31 as your answer? Or do you agree with 31 as the answer? What about part D? Find the integral from 0 to 1 of f of x dx. I think it's not possible. Some people want to say, well, it's half, right? -1 to 1. 0 would be halfway in the middle, so maybe it's just half of 5. But do you agree that we don't know what f of x is? Like, think about what kind of curve it could be. It's not necessarily going to be a symmetric shape that you could just take half of the area, which is what that number is representing. Does that make sense? It could be half, because some things are symmetric, but we don't know what f of x is. So we cannot just take half of it. So the answer is it's not possible right now. There's not enough information. Sometimes that's the answer on the AP test. Not enough information given. So I hate that answer because. So what about E? Same, not possible. Again, some people want to say we can just double it, but we're thinking about that curve itself, that function, and so we don't have enough information for part E either. And what about F? Yeah, if it just said -1 to 4 of f of x, we could do that, right? We actually did that up here already. But it also wants us to do -1 to 4 of h of x, and we only have -1 to 1 of h of x. We don't know anything after 1, so we don't have enough information about h. So we can't do part F either. And so on your homework today, you have a few of these, and sometimes they're going to give you ones that you're not going to be able to do, because that's a good thing to recognize of when you can and can't do it. Okay? All right, I got one more little theorem for you today, and then we're pretty much done. So this is kind of a definition, and then the next page it has the theorem that kind of puts it together. But this average value, and sometimes you're going to see, we'll look at some AP questions, but there's a lot of times in the AP exams they'll say, find the average value of blah, 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 blah. And it's just a formula that you have to know. And so it says, if the function is integrable, that's another word I think is made up, on a closed interval from a to b, then its average value, or mean value, that's the same as average, on the function is always given by 1 over b minus a times the integral from a to b of f of x dx. All right? And so when it says find the average value, they're going to give you a function, they're going to give you the a to b, and you're going to tell me what is that average value, and then we're going to see what that means for us. Right now, we're going to use our calculators to find the average value, because we don't know, unless we could draw a picture, I guess, if it works, but a lot of these are going to not be geometric shapes that we know. So, you just need to know the formula to find the average value of this. I'm going to do 1 over b minus a, which is just going to be 1/3, that's the part that people forget, times the integral from 0 to 3 of 4 minus x squared dx. And then I just want you to use your calculator, practice either using the graph on the graph calculate or on the Math 9, and tell me what this integral is. So I'm just going to do Math 9 and then I'll multiply by 1/3 then. From 0 I swear I did that. I really need my old calculator back. 4 minus x squared. And then you have to put comma x, comma 0, comma 3. You get 3? I'm getting somewhere. So this would be 1/3 times 3, or the average value of this function over that interval would be 1. And then my second part leads us into this theorem. It says, does f actually take on this value at some point in the given interval? And so we did this with derivatives. I don't know if you remember, like average value, mean value theorem. We had that thing when you found the mean value, and then you wanted to find where does the function actually equal that. And so what you want to do is to answer this, to find where does it actually equal that, you just want to set the function equal to this value. So to answer this, does this actually take on the value? Let's see. Let's set f of x equal to our average value and solve that for x and see, is it happened in that interval? Does the function equal 1 sometime in this interval? And so I can say 4 minus x squared equals 1, and then hopefully you could solve this without too much trouble. Subtract 4. That would just be x squared equals 3. Take the square root, and I get that this function equals that average value at plus or minus the square root of 3. So at positive square root of 3 and negative square root of 3, the value, the y value of that function is 1, which happens to be the average value of the function. If they ask you where does it take place in the given interval, be really careful. We did this back with derivatives. Are both of these answers in the specified interval? No. So sometimes any answer you get is not in the interval, maybe. But if they say where does it occur, the answer to this one would be we would only say that this occurs at x equals the positive square root of 3, because positive square root of 3 is in that given interval. Does that make sense? And though this leads us to the mean value theorem, which I think is on the next page, I don't even have an example to go with it, but the mean value theorem says that if it's integrable on the closed interval, that there will be, at some point in that function, it will take on that value, and then you can find it. And so, the mean value theorem, which we did for derivatives, says that if f is continuous on the function, if it's continuous, that there has to be some c value that equals 1 over b minus a times the integral of that. And so we'll look at some pre-response questions of where this comes into play. Like sometimes they say, like, justify your answer. How do you know this exists? And sometimes the answer is because the mean value theorem ensures that there is an answer between blah, 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 blah. And so a few questions over that thing, but not very much. I can come back to that. Questions about that? That formula will be one that you'll need to know for the test. Like without a calculator, I could just ask you to set up the mean value or the average value, not actually work it out. With the calculator, you'll punch it in, and eventually you'll work it out by hand. And then here's your homework: 1, 3, 4, 6, 8, 10, 12, 14. Sure, I could have just said 4 through 14 even. That's what people always say.